Today, we're diving into how to test the charging system using the Autel PS100 circuit tester, which has both DC and AC capabilities, similar to the Power Probe 4. I chose the PS100 because it's less complex and less cost. Both are great tools. I go into this more in the description. I've already got a playlist covering test procedures using a digital meter, but since some of you prefer circuit testers, this video is for you. This circuit tester connects to both positive and negative terminals of the battery. Ideally, the clamp should be connected directly to the lead posts, but that's not possible with this design of battery cable. I confirm the battery cables are free of corrosion and securely connected to the battery. Pushing the rocker switch to positive indicates battery voltage. The red LED illuminates, and the screen background is red, confirming B+, positive voltage, is present. With the engine off, this should be 12.4 to 13 volts DC. This battery has a surface charge of 12.9 volts because the engine was recently running. Holding the switch while starting the engine means I can watch the battery voltage drop while the starter is engaged. 10 or more volts is normal and good. Even a brief dip to around 9 volts is commonly seen, especially with colder temperatures or weaker batteries. With the engine running, pushing the rocker switch to positive indicates charging voltage. (13 to 15.4 volts DC is normal. At this point, the charging system is functioning correctly, and no further testing is needed. Let me show you how the system is supposed to work, then I'll talk about what commonly goes wrong. This component is the Rectifier-Regulator. When the engine is running, DC charging voltage comes from the center terminal. This terminal is wired to the positive battery cable. Probing this terminal with the circuit tester indicates charging voltage. 13 to 15.4 volts DC is normal. The red LED illuminates, and the screen background is red, confirming the voltage measured is within 1 volt of battery voltage. The metal case of the rectifier regulator must be grounded. Probing the metal case with the circuit tester indicates 0 volts. The green LED is illuminated and the screen background is green, confirming no excess voltage drop between battery ground and the rectifier regulator ground. This is all normal, good, and exactly what we want to see. I've set the PS100 circuit tester to measure volts AC. The outer terminals of the rectifier regulator are the AC voltage input from the stator. Each of these white leads carries AC voltage generated by the flywheel magnets rotating around the stator. With the engine running at the high-speed setting, each of these leads should produce at least 13 volts AC, likely up to around 20 volts AC. When testing AC output from the stator using a circuit tester like the Autel PS100 or Power Probe 4, it's critical to keep the rectifier regulator plugged in. Unplugging it unloads the circuit, which can cause these specific tools to display incorrect AC readings. If you need to test the AC output while the stator is unplugged, you should switch to a digital multimeter to get an accurate open circuit voltage reading.
A functioning charging system needs these three things: 13 to 15.4 volts DC at the center terminal, B- or ground, at the body and 13 to 20 volts AC at each stator lead.
If there's no voltage at the center terminal of the rectifier regulator, then there's an open circuit between it and the positive battery terminal. Notice the red LED is off and the screen background is not red, confirming an open circuit. This could be a poor connection or blown fuse. On some applications, the charge lead is routed through the equipment wiring harness and key switch, meaning additional components and connections that need to be inspected. If there's voltage at the center terminal of the rectifier regulator, but the red LED is not illuminated or is intermittently on and off, this indicates excess voltage drop, meaning there's a poor connection between the rectifier regulator and the positive battery post. A loose battery cable at the starter is a common cause of intermittent charging issues and may also cause the engine to intermittently stall, often sounding like the ignition switch is being momentarily turned off. If the green LED does not illuminate when probing the body of the rectifier regulator, then it is not grounded and will not function correctly. Loose ground connections can occur and may cause the green LED to turn on and off, indicating excess voltage drop because of the poor connection. The rectifier regulator must be grounded to the engine, and the engine must be properly grounded to the battery. When the engine is running at the high-speed setting, if battery voltage is present at the center terminal, and ground is present at the rectifier regulator body, and AC voltage is present at the outer terminals, but the rectifier regulator is not creating charging voltage from the center terminal, then the rectifier regulator is defective and should be replaced. If any stator lead indicates low or no AC voltage, test again using a digital multimeter. If AC voltage is still not present, the next step is removing the blower housing so the flywheel magnets and stator can be inspected for debris or damage. If excess debris is packed between the flywheel magnets and stator, clean, reassemble, and retest. If no debris is present and the flywheel magnets are not damaged, then just the stator needs replacement. Thank you so much for hanging out today. Even if you're not a fan of circuit testers, and I wasn't until recently, hopefully you learned something about charging system troubleshooting on Rehlko engines, previously known as Kohler engines. Thanks for watching.